Hi, in this video we are going to implement the helper methods such as this traverse, so let's start with it. If the root node is equal to a null, of course it means that the tree is empty, so we just return, and anyways we are going to call the in-order traversal. It's going to be a recursively implemented method, and we start at the root node, of course. Okay, it's going to get a node, not necessarily the root node, so it's just going to be a simple node in the binary tree. And we go as far to the left as possible. So if the node.getLeftNode is not equal to a null, we are just going to call this in-order traversal method on the node.getLeftNode. Then if it's a null, then we print out the subtree's root node, so we just print out the node, and then we go to the right as far as possible. So nodes.getRightNode is not equal to null, we are just going to call this in-order traversal node on the nodes.getRightNode. Okay, so basically that's all about the in-order traversal. As we have discussed earlier, the in-order traversal is quite intuitive. We just have to traverse the left subtree, then we have to print out the root node, and then we have to visit the right subtree. So we go to the left as far as possible, we print out that given node, okay, and then we go to the right if the nodes get right node is not equal to null. So this is the in-order traversal. For integers, it's going to yield the numerical ordering. For characters, it's going to yield the alphabetical ordering. We are going to have two more helper methods. The public integer height, it's going to get a node as a parameter. Okay, we just have to height, sorry. If the root is a null, this is what we have been talking about in the theoretical section, that if this is, sorry, not the root, but the node. So if this given node is a null, it means that we return -1. This is what we have been discussing, that we assign the height parameter -1 to null pointers. And anyways, we are just going to return the node's height parameter. It can be 1, 2, 3, 4, whatever. It's very important that if the node is a null, it is a null pointer or a null reference, we set it to -1 by definition. This is how we define the height for an AVL tree for a null node. Okay, and we are going to implement the getBalance method, which is going to public integer getBalance. It's going to calculate the balance for a node. Okay, so if the node is a null, if the node is equal to a null, then the balance is going to be 0. What does it mean? The balance factor is basically the difference between the height of the left subtree and the height of the right subtree. So we just have to return the difference between the height of the node getLeftNode, which is basically the left subtree, and the height of the node.getRightNode, which is basically the right subtree. So we calculate the left subtree's height, we calculate the right subtree's height parameter, and the difference between the two of them is going to be the balance factor. It's very important that if this balance number, this balance factor, is in the range -1 and +1, it means that the tree is balanced. Basically, the left subtree and the right subtree height parameter doesn't differ more than 1. If this difference is greater than +1 or smaller than -1, then we have to make the rotations. This is exactly what we have been discussing in the theoretical section. Okay, so that's all about this getBalance and the height method. In the next video, we are going to implement the rotations and we are going to talk about the insertion. Thanks for watching.